Okay, everybody, I'm back. Now, we've given this thing a conventional charge and we're just going to let it sit. And what I had to do was start the chart over so that we could continue this because I ran out of memory. So I'm going to see if I can auto scale this. At 1,000 samples here, and so we can see here where the battery's settled. And now we're going to turn the load box on, and the load box is going to draw just the fan current because it's all self-powered. And once again, you can see that there's no green light. So what I want to do is I want to load this battery at the 12-hour rate. So I'm going to use the third button here. And remember, I said to you that this was a 30 amp hour battery typically. Okay, so as you can see, an Alum battery does not react like a lead acid battery. And just because this number 1186 here, according to our chart, doesn't mean that this battery can't supply any energy, because it's going to fall to a spot and stay here at 12 amps. Now, we want to check one thing, and we want to make sure that the load bank is working correctly. And so you can see here it's very close to 12 amps, 11.93, 11.92. So we're corresponding with the current in the load box. And I did make an error in an earlier part of the video where I called it 6 volts, and it was actually 16 volts. So I want to correct that with you right now. Now what I want you to understand about this battery is was a throwaway battery, and I washed it out and converted it to Alum. ALUM, food grade Alum, at a 10% mix rate for the 4 ounces of water. Okay? These converted batteries do not act like a normal lead acid battery, but that does not mean that they don't work. They do. So let's see here. Here we go. Let's go. And of course we drop down to our level where this wants to run. So as you can see, it's gathering the information now, and we're going to see what happens here at this 12 amp hour rate, because anything that I would be doing here in the shop with my motors or with oscillator circuits or anything like that, I wouldn't be pulling over 6 amps or 3 amps, as I don't believe in that. So I say the less current you can burn in your circuits, the better off you are. Anyway, we're going to watch this battery and I'll be back. Okay, as you can see, our curve is pretty flat, and it's going to stay like that, as this battery was considered a battery that's just throwaway. So for around here for testing, this converted battery does real well for me. And as you can see, it's got a pretty flat curve when you load it correctly. And even at loading it, even if we took this up to 30 amps right at this moment, it would go. And I think we'll do that just to show you. We'll just tell it to go to 30 amps by pushing the last button. And of course you can see the chart's going to correspond with it. So we'll just leave it at 30 amps for a few minutes, and then we'll reset it, go back to 12 amps so you can see how it recovers adjustment-wise. But I don't know, it's going to stay pretty flat there. So it can do that easily. So you're right about within its amp hour range right now. And this is all that the battery technically can supply. But, however, you can take this down to a much deeper level than you can a lead acid battery without damaging it. So we're just going to watch what it does on this curve, and as you can see, it is underneath a little bit there, and it's going to fall off like a normal battery. So we'll let this go a little bit longer, and then I'll reset the load box and show you what happens under the different loads. I'll be back. Okay, I'm back so you can see the curve of how this curve is corresponding. Okay, and I want to show you the load box. It's at 31.57 amps. And it's been doing this now for about 10 minutes here. Maybe 12 minutes here. Okay, so now if we reset the load box, we're going to watch where the battery recovers to. I want to point out to you guys, meters don't lie, and charts don't lie. It's how you interpret these charts for the battery you're working with. So now let's just go back to the 12 amp load. In fact, let's do one strange thing here. Let's go to 50 amps just for a minute, as if we're stepping on an accelerator. And of course this meter is overloaded. So if we were accelerating, this is exactly what happened if you hit the pedal on a golf cart. You would see this sudden dip. But look where the battery is. At 50 amps. So for a battery that's a throwaway battery running a 50 amp load, I would say that this battery is doing pretty well for something that was going to be scrapped. Now if we reset this, which you can watch me do, you can watch the battery recover again. And you can see it corresponding on the chart. So now we go back to our 12 amp load, which is going to be this third button, and that's close, 11.6, and we'll just let her run out and I'll be back. Okay, I'm back, so you can see now this is about maybe 5 minutes here, and you can see the voltage at the 12 amp load. So we hit it with the accelerator on the golf cart. It went down to this level, then we let off, it recovered, and then we hit it again, it recovered, and then we're at a 12 amp load right now, as if you were just rolling along. So the next thing that I want to do is hit this with one of these rejuvenators right here, and really sock it to it with a rejuvenator. That's going to be a little bit different than the conventional charger we used at the beginning here. So one's going to change the pulse rate, and one's a conventional solid charge, and one's going to be at our charge rate with the rejuvenator. So I'll be back. Okay, this is going to take a while to run out, so what I want to do is I want to hit this with the rejuvenator. So I'm going to 50 amp this thing to death. And then of course you can see At that voltage level, I'm 40.9 amps. And I've dropped down here now and I'm going to let the load box decide when to shut this battery off. So it's at 11:11 right now, but after it got used a little bit, it's not falling as fast as in the beginning when it wasn't used, because it's been charged. So when again, I'm going to point this out one more time, that the converted lead acid battery does not work the same way as a normal lead acid battery. There's a little difference to it, but it does not mean that it cannot carry this load, which it's doing. So I would have no difficulty starting your car or running the lights. So I'll be right back as soon as this gets ready to cycle. Okay, I'm back here, and you can see we're approaching this level here, and so pretty soon this box is going to decide whether or not that the battery can take any more of this load. But you can see the curve. It's still at a continuous 40 amps, 40.2 amps, all buttons on for 1/4 of an ohm. And the 5 comparators inside the box are going to decide whether or not this should go forward and draw down even further. So I'll probably miss the turn off, but I'll come back and show you where it turned off and where the battery recovers to. Then we'll hit it with a rejuvenator. So I'll be back. Okay, we're at this level now, and it's continuing to hold there. But we can see that the curve is going downward now. Now normally, this type of battery is considered dead at 12 volts. But you can see this is far from dead. And so, as this thing decides, we're going to take every amp hour out of this battery that we can take out safely. So, there it goes. Okay. So now we don't need the load box anymore, and I'll be right back when the rejuvenator's hooked up. Okay. So what I gotta do is hook our chart up, which is here and here, and that's where our battery came back and settled. Okay, so go ahead and hit the rejuvenator, Tom. Okay, and right away the rejuvenator's putting the current to it, about 31 amps, and you can see it here corresponding. This is where I disconnected it, and then this is where I put it back. So rejuvenator is going to bring this up, and then we're going to go for the 50 amp test. You can see what it's doing here and how it's corresponding on the chart. So we're at about 2 minutes here. So you can see that this battery draws current the same as a lead acid battery. So I'll be right back. Alright, now our time scale has changed here. As you can see, it's moving in and out, but it's kind of hard to see, but see if I can get it in here. On top of the charging curve, there are little spikes. And that's what the rejuvenator is doing. It's injecting these little spikes into the charging current. So we're watching this now, and you can see the battery's at 13. It's just charging it, discharge, charging it, discharge, charging it, discharge as it goes up the curve. So I'll be back as soon as this curve gets a little higher. Okay, now I'm back, and you can see how this curve is going on the charge on the rejuvenator. You can see it's going to rise up now pretty soon, and we'll be done with that charge, and then we're just going to load the crap out of this battery at 50 amps. And that'll be the conclusion on my conversion with the Alum. And I just encourage you all to experiment with the batteries, but one thing that I'm going to bring up to you right now is you must make sure that the battery is not shorted, doesn't have any cracked plates, and doesn't have a dead cell, or you're wasting your time. You're not going to resurrect something that's shorted. And I'll be back. And you can see that this is towards the end. This is where the battery, notice this, the way it charges this battery. Flat, 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 ever so slightly upward. And then all of a sudden, see the battery's chemical is now almost approaching a full charge with this battery. And now the only thing that can happen is this can go up and flatten off. After that, you're just wasting the energy, so you don't need to charge it anymore. So I'll be back as soon as this takes a turn here. Okay, this is how the curve's going to look under the rejuvenator charge. See, it's flattened off here. See, it's not going to overdo the chemical. So as you can see, the battery is now at 15.757374, and the rejuvenator now is just going to continue to pulse at a lower rate, and that would be indicated by a green light on the rejuvenator right there, saying that your battery's charged. The red light's indicating that it's still taking the charge, but now it has changed its cycles. And see, 23.4 amps right there in spikes. So you can see on the curve the little jitter at the top here, and that's just being flattened off right now. There you go. And it's just going to stay there, and it's not going to overdo the chemical, because that's what you don't want it to do. You don't want it to boil the battery away where you lose the electrolyte in the battery. Okay, now I'm at the last part, and as you see, the rejuvenator has held this at a flat charge rate on this battery, and now we're going to turn it off, and I'll be right back. Okay, now you can see that the battery's flattening out here, and where the voltage is after the rejuvenation charge, which means that the charge is much denser than what the rejuvenator did, because I don't think it's going to come down much more than that. So we're going to start the load box. We're going to go by this meter, and as I said to you, I'm going to hit it with a 50 amp load. So here we go. Okay, and you can see that we hit that. I'm going to try to expand this out. Okay, and you can see it there. And we're just going to let it go on this charge. We're going to give you exact minutes. And we're going to time it out with a timer. So there's the step, and we'll just let it go, and I'll be right back. One thing I'm going to point out here is notice, look at the current, 48.3 amps now, not dropping as fast, and holding the voltage much more than what it did before. So I just wanted to point out to you that on an Alum battery it also depends how you charge it. So we'll just let her go and find out what happens. Okay, now we have this time at 50 amps, and what I'm going to do is release this for a minute and come down to a 24 amp load just to see how the battery recovers. And you can see that the battery starts to recover at 24 amps. So this was like a continuous load for 11 minutes here. Continuous 50 amps for 11 minutes. And then I wanted to see how this battery would recover in the end after this charge. And then you can see it here, that it's going to stay pretty stable there. So this is at 25 amps now. But at this voltage it'd be a little bit less, it'd be about 21 amps right here. And that would be at 11.36 volts. And so this sort of concludes what I wanted to show you about the Alum battery, and you can see that here's where I switched in the loads to make 50 amps, and then 50 amps for 11 point something minutes here. So I drew that 50 amps completely out of the battery for that time period, switched out of that load, went to a 25 amp load, and now I'm just going to let the battery run out. But that's what you can expect when you convert a battery with Alum that they tell you is a throwaway battery. So, as I said before, you know, you can only be as good as what the plates are left in this battery. And so, I hope this helped you guys. See you later. Bye.